Hi, okay, well, just to quickly review a little bit about our project that we've been working on. So we're trying to come up with a way to simulate SRAM, which is the RAM that's used in the fastest part of the computer called the cache. The SRAM stands for static RAM, random access memory. So the static RAM doesn't sound like it's fast, but it is much faster than the normal type of RAM that you would go out and buy over at Best Buy or someplace like that and install into your computer. The SRAM, the type that we're using, the cache, is located right in the processor. So the closest RAM to the processor is called the level 1, the L1. If it's a little bit farther away from the processor, it's the L2, but still possibly on the same substrate. And if it's removed a little bit further away, there might be an S3. Sometimes there's no L3, I should say. Sometimes there's no L3. But the L1 is the closest, the L2 is next closest, and that's going to be pretty consistent. And then possibly there's an L3. So the SRAM, the very fast RAM, the cache, is where you're going to have the instructions look to first to see if the data is there. And if it's not there, there's a process where they're going to go ahead and pull the data from the regular RAM, the DRAM, and bring it to the SRAM. So the SRAM is cache, which is very important. So that's why this is a very important project, just to get everybody back up to speed on what we're doing here. So we were able to actually, with pieces parts, at the chip level, using 74 gates, the 7400 LS TTL type logic gates, we were able to put together small registers of the SRAM, of the cache memory. So now our next step was just to simulate it. So we wanted to go through a simulation using the Arduino. And the simulation on the Arduino turned out to be very, very difficult because there's a number of steps that you have to go through in order for the thing to work. And it's a little bit confusing where to move the wires and so forth. So that's kind of like where we had some issues, and what we're going to do today, we're going to go ahead and look at the simulation that I think it was Yi, June, and also Yusuf's team. They came up with a solution that was pretty close to being finished, but not 100% finished. So our project is to completely finish up the code to simulate the cache and the situation where we're able to use the simulation to show how the operation works with the SRAM. Okay, we're on the workbench, and we have an Arduino Uno set up over here that's powered on, and our breadboard shows us the data bus over here on this side. This is the data bus, and it shows us on the other side the registers. So what's inside the registers is over on this side, what's inside the data bus is on the other side, and we're starting off with 0, 0 on the data bus. So that data is coming in, and we're going to save it in register 0, 0. That's our first initialized step here that we want to do, zero everything out. And this wire that I have here, this is number 13. This is our read write with a bar over the W. So I'm looking at my picture that I have with my code page, and the bar over the W signifies that it means a low will cause a write into the data register. And that's where I have it right now. I have it on ground. It's probably a little hard for you to see, but I have this pin 13 set to ground, causing it to write. But it will only write once I clock in to the flip-flops. So I take a pin 12, which is what we're using in our code for this Arduino project, and I go ahead and momentarily tap it to ground. And that activates the clock, which latched that data 0, 0 on the bus into register 0, 0. All right. Now I'm going to change my address to my register. And I'm going to write, I'm still on write, I'm going to say, okay, let's put in 0, 1. So that's the binary bit 1. And I'm going to go ahead and do that now. So see, I'm setting up my data as a 0, 1, least significant bit being the 0, 1, and then I'm selecting location 0, 1, and I have to clock it though, so let me go ahead and clock that in, and now I clocked it. I momentarily touched pin 12 to ground. That latched this data into the memory register, the cache memory. Now let me go ahead and change it again. So I'm going to go to location. These are my locations, my address. I'm going to 1, 0, which is the number 2. So we had 0, 1, and now we have binary 2. And let me also change the data to reflect that, just so that I'm consistent and I can see what's going on. So now I've put the data, least significant, most significant. So that's a 1, 0, and that's going to go into register 1, 0 when I clock it. Let me do that. Clock, momentarily touch to ground, so it should be latched in here now. And my last register, the 4th register, location 1, 1, we'll put in for the heck of it. Again, this data would be, changing with whatever is actually happening in the computer, but just for practical purposes for us to observe, we'll change it to now also 1, 1. So there's my data, 1, 1 on the data bus. I'm going to lock it into my register when I clock it, and bingo, there it is clocked. And now I change my read-write from no longer being grounded, no longer writing, it'll go to a read, and let me put everything back. My register will start at 0, 0, and we'll go through each one of those register addresses and see if our data is actually latched in there. So let me go ahead now and change my pin 13 to read. So now when I go to read, 0, 0, that's where we started at. And now I go to 0, 1, and there it is, least significant bit, most significant bit, least significant, most significant bit. It put in the number 0, 1 in the register in storage, and is also now, since I'm reading it, it's sending it out to the data line. And let's go to the next register location, which is 1, 0. And there's the 1, 0 data that we had stored now out on this way out to the data bus. And finally, the last memory location was register 1, 1. When I go to register 1, 1, there's the data that I had put in there, 1, 1. And now that's on the data bus. So that's our simulation, and I think it's pretty cool. A little bit confusing, I grant you that, because of the wiring, but the concept is really cool.